Project Deployment, Installing WAP Cabling. By the time you're done here, you will understand cabling requirements for wireless access points. Setting up wireless access in an environment like this is awesome. You have the pure adrenaline rush of, yeah, we're going to mount wireless access points right here, and you end up getting a lift, and you're hanging upside down on scaffolding trying to mount this thing. You're like, this is great. But maintaining wireless access in an environment like this is not fun at all. What I mean is when one of these wireless access points goes down and your controller is telling you it's disconnected, your stomach sinks because there's no more adrenaline rush. There's nobody here that will tell you, great job fixing that WAP. All it is hassle. You've got to schedule a lift to come out. It's got to be after hours. And you know it's going to be something dumb, like the wireless access point has to be rebooted or something. That's why the type and the number of Ethernet connections you run to one of those wireless access points is really important. Some of the wireless access points that are out there only support a single Ethernet connection. And that may be okay as long as that supports power over Ethernet. Now in the next nugget, I'm going to talk all about powering wireless access points and your PoE options and things like that. But we want the ability to power off and power on that wireless access point remotely, and we only get that if we have power over Ethernet connections. Some of the wireless access points will support dual or more connections that serve a variety of purposes. Our wireless access points have evolved from the day of being 11 megabit per second devices. Nowadays, as you might have seen in one of the previous nuggets, they're coming out with that 802.11ax standard, which is talking about 10 gigabit per second over wireless. Well, our standard gigabit Ethernet connections hit the capacity when they get there. So a lot of times you'll start seeing wireless access points that have more than one Ethernet connection that you could bundle into a lag. And that means that you can splice that bandwidth together so you have increased capacity there, and it gives you a level of redundancy. If one of those Ethernet connections fail, the other one stays online. Now you might also see pass-through Ethernet ports. For example, this might be your incoming connection from the switch that connects to the wireless access point, and then you have a secondary port that passes through to some other device. Maybe in the ceiling you've got your WAP, and then next to it is mounted a video camera or something that's able to, give you some IP surveillance of whatever swimming arena we're at. You could take that cable and literally daisy chain it through, but keep in mind that one is not going to support PoE passing through it. You might also see wireless access points that have a console port in them. So in that case, you want to run two Ethernet cables to that wireless access point. One of them will be for data, and the other will be for management access. That means if the wireless access point crashes or it's just reporting inaccessible in some way, you'll often be able to connect to the console port, which is kind of like hooking up a monitor, if you will, to that access point and getting into some command line syntax that can help you manage and reboot and bring that access point back online. My point in all this is don't assume that you just have a single Ethernet connection that you're going to run for every WAP. Look at your WAP and look at the Ethernet port options that it gives you. Now heading back to the project at the church, I actually divided it into two separate projects for cabling the WAPs. The first one was to move the MDF, and I put it in quotes because that was the previous MDF that existed. That room would regularly reach above 100 degrees Fahrenheit. It was amazing that what little network equipment they had didn't just burst into flames immediately. So what we did was we actually ran a couple cables into that room and fished them to the new MDF location. I met with the administration and they decided to put it into that office area, so we installed some power right there on the wall, put some plywood to back it up, and installed a cabinet. Inside of that cabinet, we installed the core devices, a switch, a router, and a UPS power supply. And that moved us into project number 2, which was cabling the WAPs. That was where we ran cable from all the locations that those WAPs would be to the location of the new MDF. This is where that box is now sitting on the wall. That's the location of the previous MDF. While I took video of that entire project, it is a direct overlap with the IT Expertise cabling series. As a matter of fact, for the project that we did in that series, I used that exact same cabinet, exact same switch, UPS, router. It's all the same. So if you want to know how to set something like that up, head over to CBT Nuggets and look for IT Expertise, installing network cabling and devices. And if you're just getting started in the realm of IT, this series will give you everything that you need to get your foot in the door. Now, I promised at the beginning of this series that you will understand WAP cabling requirements. And now you've got it. In our deployment, I only ran one cable per WAP because the Ubiquiti WAPs, while they do have a secondary port, it's just for a pass-through. And based on the design that we put in place, I don't see us needing a pass-through for any devices near the WAP anytime soon. I hope this has been informative for you, and I'd like to thank you for viewing.